Hey everybody. Today we're getting started with transformations of functions, talking about shifts and flips. Modifying the formula for a function often changes the graph in a simple and predictable way. For instance, let's look at this graph here, y equals f of x, and see what happens when we add or subtract 1 to f and when we add or subtract 1 to x before plugging into f. If you add 1 to the function, you're shifting the graph up by 1 unit, as pictured here. Here, the dotted graph is representing the original function, and the solid graph is representing the shifted function. That's going to be the case in the next few slides as well. Similarly, subtracting 1 from the function is going to shift the entire graph down by 1 unit. Adding 1 to x before plugging into the function shifts the graph 1 unit to the left. So, for instance, if you're evaluating the shifted function f of x plus 1 at x equals 2, that's going to be the same as evaluating the original function f of x at x equals 3, one greater x value. Similarly, if you subtract 1 from x before plugging into f, that's going to shift the entire graph to the right by 1 unit. For instance, if you want to evaluate f of x minus 1 at x equals 2, that's going to be the same as evaluating f of x at x equals 1. Here's a quick summary of those last 4 slides. Suppose you want to graph y equals f of x plus c, so adding a constant outside of the function. You're going to shift the graph of y equals f of x vertically by c units. You're going to go c units up if c is positive, and you'll be going down if c is negative. If you've got to graph y equals f of x minus c, so subtracting c inside the function, that's going to shift the graph of y equals f of x horizontally by c units. You'll be going to the right if c is positive and to the left if c is negative. Notice that inside that function it's x minus c, not plus c. It's very easy to get that backwards. It's a shift to the right if you're subtracting a positive number. Let's work through some examples. First, let's graph y equals x minus 2 quantity squared minus 1, starting from the graph of y equals x squared and applying some of these transformations. So hopefully we all know what the graph of y equals x squared looks like. It's a parabola whose vertex is at the origin. The first thing we want to do is to replace x with x minus 2, inside parentheses of course. That's going to shift the graph to the right by 2 units, as we can see here. Next, we need to subtract 1 from the whole function. That's going to shift the graph down by 1 unit. Overall, this is the graph of y equals quantity x minus 2 squared minus 1. Okay, now let's think about reflections. We're going to be looking at y equals negative f of x and y equals f of negative x. Let's go back to this original example and see what the graph looks like in each case under those transformations. When you put a negative sign outside of the function, you're reversing the sign of each one of the y values. If the y value was positive, it becomes negative, and if the y value was negative, it becomes positive. So the net effect is going to be to take the original function and flip it over the x-axis, a reflection. If you change the sign of x before plugging into the function, you're going to flip the graph over the y-axis. You're going to change the sign of all the x values rather than the y values. So here I've pictured the graph on separate axes because it ends up being more clear that way, what the transformation is doing exactly. Let's do another example. Let's use the graph of y equals the absolute value of x to plot y equals negative the absolute value of x plus 2. So here we are going to have a vertical reflection with that negative sign out front. We're also doing a horizontal shift, replacing x with x plus 2. Now in this particular case, the order doesn't end up mattering, but often the order does matter. A good rule of thumb is that you should always work from the inside out. So the first thing we're going to do here is to replace x with x plus 2 inside the function. And that's going to shift the graph horizontally. After that, we're going to do a reflection. Here's our original graph, y equals absolute value of x. Now let's replace x with x plus 2. That's a horizontal shift to the left. We know that when we do x minus c, we move by c units to the right, so here c would be negative. We're going to the left. Next, we put that negative sign in front to reflect over the x-axis. The graph y equals negative the absolute value of x plus 2 is shown here on the lower left. It comes up getting bigger until we get to x equals negative 2, and then the graph seems to reflect off the x-axis, getting smaller again as we move away to the right from x equals negative 2. Compare the graphs of y equals negative the square root of x plus 1 and y equals negative the quantity square root of x plus 1. So both of these graphs are coming from the simpler graph of y equals the square root of x that I'm showing here. And in each case, we're going to need a vertical shift when we add the plus 1. And we're going to need to do a reflection over the x-axis when we put in that negative sign out front. In this case, the order of operations makes a big difference. Here are the two graphs. When we're doing the y equals negative the square root of x plus 2, which is the graph in the middle here, first we're doing the reflection, y equals negative the square root of x. That's reflecting the dotted graph over the x-axis. Then we do the vertical shift, shifting that graph up by 2 units. On the other hand, the bottom graph here, y equals negative the quantity square root of x plus 2, starts with that vertical shift. So we take that dotted graph and move it up by 2 units, and then reflect the whole thing over the x-axis. For instance, when we shift it up by 2 units, the point that was at 0, 0 moves up to 0, 2. And then reflecting it over the x-axis will change the sign of that y value, moving the point 0, 2 to 0, negative 2. One final example. The graph of two functions are shown below. What transformations have to be applied to y equals f of x to get the graph of y equals g of x? So first let's just do this in words. And then once we have a verbal description of what transformations need to be applied to f to get to g, then we'll be able to write a formula. It's clear that we're going to have to do a vertical reflection. So let's do that first. Let's replace y equals f of x with y equals negative f of x. Now I need a horizontal shift. I need to horizontally shift 4 units to the right. And of course, that's going to mean replacing x with x minus 4. Overall, the formula for g of x is going to be negative f of x minus 4.